Let's welcome Rambiba.
Thank you, Bill, for introducing me. And hi, everyone. Let me share my slides. Which, okay. Okay. I'm guessing my slide is visible and I have two built with AI. Okay. It's a little bit weird. Hi everyone, today I'm gonna explain a little bit on Gemini and Gemma. I think Nikhil has touched on a lot of these things already. So I'm gonna touch a little bit on the other parts. For example, what are the things which you right now have in available in Google Cloud Platform that you have already seen, but some of the things what you can do with it. And also we have like two parts of this talk, which is one I'm gonna concentrate a little bit on Gemini and then on Gemma, which is the open source model, and some of the tooling part of the like what you can do. So this talk will go mostly what you can do, a little bit of demo and share the resources, and then we have a lab later, which where we can go hands on exactly how you build those devices. Okay, so a little bit about myself. I'm Rabimbo. I'm a Google developer expert in AI ML. I'm also a cloud champions innovator and cloud research innovator with Google. I'm a, PhD student, so I am studying, and this is kind of also my research. So, starting with Gemini. Uh, okay, so this is supposed to be the demo which Nikhil just talked about that, okay, you upload a Sherlock movie and Gemini can kind of like explain what's happening, just the uh, like a clip, and it can actually go through it. This was a video which was supposed to go through that. And I thought since he has already explained about it, let's actually look at if you want something like this to happen, what you will do. So we'll immediately jump off to a demo. So let me share my different screen, which will be this. Is my screen visible? I hope it is. Yes. Can I get a comment or something if my screen is visible? Like with a collab? Okay, nice. So let's see what we have to do something like that. I'll explain the steps later, but since this takes time, let me just run it. So these couple of steps, I'm just initializing Google's generative AI library from PyPy and adding my Google API key here. Then I'm downloading this file. This is the Sherlock Junior 10 minutes video, which is supposed to be in that demo. So I'm just running it directly. I'm just doing that. And then I'm going to download and extract the images frame by frame, 1 frame per second. So this is different from what Nikhil was showing in his last demo in GCP. That works a little bit different way. We'll see how it like what is the difference. Anyway, so since this is extracting frames 1 frame per second, we will see here after some time, and then we want to get timestamps to see what's happening. Then we want to see the list of files, and then we will work here. Until then, let me go back to the previous slide. Okay, so while that is happening,
This is a demo of
let's look at some of the things we can do with Gemini right now. As you can see, Gemini is a multimodal model, and it can work on images, video, text, and Gemini 1.5 can also work in audio right now. So these are the things which you can already see if you log into your Google Cloud platform. You will have access to 1.0. Some of you, if you have gone into through a waitlist, or if you eventually go through a waitlist, you will also have access to Gemini 1.5 and Ultra, but that's kind of like a case by case basis. Most of the things we are going to talk about today, almost all of the things we are going to talk about today, you can do already with Gemini Pro 1.0. Let's go back to our collab, see it's getting uploaded. So these are the frames which we extracted and it's getting uploaded. Once it's done, so we have uploaded 10 files. I want to see that if all those are there, they are there. Now we ask it to describe the video. Okay. Okay. So as you can see, the prompt I have given is describe the video in detail and also describe the plot. And the model I'm asking it to work on is the 1.5 Pro. Now, when I run it, it's doing the request here, and okay, this is what we got. The video is a black and white silent film. The first scene shows two men walking on the dirt road in a residential area. There are several houses and cars in the background. The two men walk past a train car on railroad track. The background, there are all dedics. One of the men tries to jump into train car but is unsuccessful. So this is if you how you use if you use Gemini 1.5, this is how you can use it, and it can tell you, it can understand the video, what's happening and what's happening there. Then we just delete the files and we go back to our tab. So that's the power of like a huge context window. We were able to send and you can actually send a much bigger file. For the demo, I intentionally did it very small. So you can send these and you can actually have understanding on that. So going back to Gemini 1.5. So Gemini 1.5 is a mid-size multimodal model, the Pro model, and it's a mixture of experts model that works in a little different way than our models. So while a traditional transformer function as acts as a one large neural network, mixture of expert models are divided into smaller expert neural networks. Uh, so 1.5 Pro maintains high level of performance even as its context window increases. So why context window is important? So imagine if you have a conversation with it, which you have done pretty, I would say early. By early means after that you have a long other part of conversation or long other documents sent through it. It still should be able to remember the very first or the very initial part of it. So this is called kind of like a needle of in a haystack. So you give it a lot of information and you try to get, or you try to get answer very specific to one information which was part of it in a very beginning or any part of that. So a big context video helps immensely with it. So with Gemini 1.4, almost 99% of the tasks, the embedded text, these blocks, you will be able to get that back. So 1.5 Pro can process a vast amount of information in one go, including a 1 hour video, 11 hours of audio, and code bases with almost like 30,000 lines of code, or maybe like 700,000 words. Uh, what it means is that you can literally pass multiple GitHub repositories of code, lot of files, and ask it to code based on context of all of those files, not based on what it already knows, not based on only one part of the file. So it has bigger understanding of what libraries are getting used, what are the different associations between them. So let's look at what you can do with these in Vertex AI. So right now in Vertex AI, you have all these models available, which is there are different choices. These are kind of like the 6 examples of models. These include text, dialogue, code generation, code completion, image generation, embedding for downstream machine learning tasks. And beyond the choice, you have also built-in safety and governance, access to the best of state-of-the-art models, which is not necessarily Google's. For example, all the Hugging Face models, Mistrals, Claudes, Metas, open source models. You can have access to all of them through Model Garden. Now let's talk a little bit about Gemma and why we might want to even consider Gemma, or why that's important for us. So Gemma is Google's family of state-of-the-art models built from the very same technology or research which has been gone into building Gemini, but these are all open source. Why? So let's address the open source versus open model in this slide. So Gemma is open model built for responsible AI development from the same research that used to create Gemini models, meaning the weights are freely accessible. So anybody, if you're a researcher or if you just want to play with change certain things which are not available with commercial APIs, you can do that because you can have weights, you can do much other things with this apart from just fine tuning. Uh, why we won't say exactly open source, specific terms of use applies to that. Gemma has something called Gemma license, so you can use them freely. Users can even create and publish modified version of it. However, the terms of use prohibits harmful application, ensuring responsible AI development. So that's one of the tidbits you have to be careful about. Now, Gemma models, there are two models available right now. Gemma models has been trained up to 6 trillion tokens of text using very similar architecture, data, and training recipes as Gemini model family. And the Gemma model architecture based on the transformers decoder with improvements such as multi-query attention. These models, at least until IO, these models are not multimodal and multilingual and best used for language tasks, specifically, for example, question answering and summarization. You will be able to find open source models which have been trained, so which have been fine-tuned on different data on Gemma, which are able to do even the specific Gemma without any change. It can unofficially talk in different languages, but that's not something recommended. I can actually show that. So these models achieve strong generalist capabilities in text domains, and the reasoning skills also come with the skill. There are two specific models available. So one is the 7 billion parameter model, which is more efficient for deploying and development on GPU and TPU. And then there is a 2 billion parameter model, which can literally run in your mobile devices right now. We will have a demo on that. So this is mostly suitable for running in CPU. So some of the benchmarks, you can see the link on the bottom. That's where the technical report is published. So as you can see, language understanding and generation performance of the 7 billion model across different categories compared with similar sized open models. And you can see this performs pretty well compared to different similar sized and sometimes even bigger sized models. I can see a couple of comments that it's small and blurry in the screen. Um, Bill, can you see the slide properly?
Yeah, I think it's fine. Just the coding part, you probably need to like a room
Okay,
in
next
larger.
time I'll just make it bigger.
Slide is fine.
Okay. So how does it fit in the model ecosystem? So these are separate model families, and you should look at for your use case. So for example, Gemini is Google's most capable AI models, and you should use it for mostly production offerings if you want something already pre-built and have little tinkering use case for you, or if you want to fine tune it and if that fits your use case. Gemma is for more advanced usage, for example, for doing it as a like research task, or if you want to have it in a use case where Gemini might not be fit or on device. So there, Gemma actually shines for your use case. Now, both of them, you can actually don't have to work in your own machine. Both of them works completely fine in Vertex AI as well as Google Container Services. So you can just put them in GKE and you can build your own custom models, like custom use cases with that. Now, this is mostly for developer experience walkthrough, what you can do with it. So Gemma and Google's ecosystem is that you can actually use everything we will be talking about today in GCP right now with very little friction. Gemma is available with all the popular frameworks, and users can easily do inference on fine tuning using Keras multi backend feature or natively in JAX or PyTorch. And also, some of you might be familiar with Llama CPP, like an open source project where if you have a model, any of the open source models in a specific GGML format, you can just do inference with it, just kind of plug and play. You can do that with Gemma as well. Gemma already comes with a GGML model, but the Google team has come up with a similar Gemma.cpp, which is a very optimized inference engine written in C++, and you can actually use it as an inference engine directly right now, and it will also run all the Gemma models completely fine. Now, if you look at the Gemma and Google AI ecosystem, this is just screenshot from like a Google Colab, which I just showed, and this is how it works. I thought the previous example was not very clear, so we'll go through that, some like a new example later. Now, let's see what we can do with Gemma on Vertex AI. So there are multiple ways you can have access to that. So for example, if you go to Hugging Face, there is a Gemma CPP model. And if you click on deploy, you will have something where it shows deploy on Google Cloud Platform. It will directly redirect it to Vertex Model Garden in Gemma deployment page. So if you go to Kaggle, if you're a Kaggle master or you're familiar with Kaggle's interface, you can go to Kaggle and you can just click on Open in Vertex and it will redirect to Vertex Model Garden Gemma page. So this is how it looks like without signing in GCP. So you will have this page where you have deploy, notebook, and fine-tuning pipeline. All of them will ask you eventually to log in. So this is literally how you will use. You will say that, okay, I want to sign in, and you will be deployed. And if you want to deploy it in your own container services, so this is how you can deploy it in Google Kubernetes Engine. So here you have the whole Kubernetes engine, how it was before, but now you can add, so the AI ecosystem, the model garden allows you very easily to have this component where you can train, inference, or even you can do fine tuning. So if you want to deploy it, so from model garden, what you saw in the previous talk, you can just go into that deploy and it automatically gives you a page that, okay, it provides you Google Kubernetes Engine as a target. And you have specific configurations which are already there for you. And you can also have different ways of employing it. For example, it will recommend Hugging Face's TGI. If user is coming from Hugging Face, it will go for the LLM VLLM default if you're not coming from Hugging Face. So from Model Garden, you can also directly go to Kubernetes Engine notebook. So it will directly open it with minimal friction. So you can use this not only with GPU, you can also use it with Google's Tensor Processing Unit, which will vastly make your fine tuning or text generation process faster. These are all optimized right now and available for most of the popular frameworks available. So PyTorch, JAX across GPUs and TPUs. As you can see on the right, so So you have two options, so either in TPU or in GPU. So when I said the VLLM, the Hugging Face TGI, these are all GPU-based frameworks. So these are all available in the GPU part. Google has also partnered with NVIDIA, so TensorRT LLM is also available within GPU. So these are kind of the offerings you will be able to use already. So VLLM is highly optimized for serving LLMs, and this is hugely used by open source community. So you have access to that. Hugging Face text generation interface is another one, and then NVIDIA's highly optimized TensorRT toolkit. So these all are immediately available, and you don't have to go for any other plumbing to actually enable these to Google Kubernetes Engine. So this is how the whole family looks like. So in cloud, you have the tools and libraries, which enables you to work with these frameworks. And then you have these frameworks. And then you have the GKE, which takes care of the infrastructure part. Now some of the Gemma resources. Now let me share this tab instead, and let me make it bigger. So is this visible now properly? Can I get just a thumbs up or something? Yes. Okay. So this is kind of a demo what we want to do. What exactly you saw in the previous talk, that okay, if you just put two PDFs in GCP, that was using just normal UI, and you ask questions on the PDF. I wanted to see that, okay, if we want to do the same thing in just programmatic way, what we can do with that. So this is what we are going to do. So I have a Google Colab archive reader, and I go through the same steps. Yes, of course, it's not authored by Google. And these are the basic initial building blocks. I install the generative AI library. I initialize that. And I install some PDF processing tools. We use popular utils. You can use anything you want. Now, this is working in a little bit different way than how the GCP demo was working. We will go through what is different. So now I want to download and process a PDF. So this is a PDF in archive. This is something of my own. So I just point towards it, and yes, it downloaded extracts page. So it downloaded everything. I want to extract page 149. I think that was for a different one. Let me see which one was this. Yes, okay. So why page 1 to 9? Because most of the research papers will have things like references and everything. If we want to ask questions on it, those are not the things we need to, like, we want to even pass to an LLM. So I just want to pass the actual texts, which will still have some references, but we're fine with it. So I just extract page 1 to 9, and then we extract those as JPEG images. And I want to see the output. So these are the image outputs I got. And I want to see if I extracted the right thing. So we'll try to see. And okay. Yes, of course, because okay. And okay. So this was the paper, and yes, we want to see the first page. This is a JPEG image, and it got the right one. Now we also want to extract the texts from the same pages. So we go through that. This is the output. So now we have with JPEG, we also have the TXT files, and I concatenate all of them. And then we assemble all the files into a prompt, and we upload them using the API. So here we are using the Gemini upload files to upload the images, and it's 100%. So we also load all the text and we have to combine them. Now let's try it out. I'm trying it out with 1.5. And so first I just want to summarize it. Oh, actually I want to do more. Okay, so we want to summarize the paper and also see what are the contributions of the paper, the strength and weakness of the paper. So this was a different paper. Once this process is done, we'll see if it is working. Okay, then I want to display what we got. Okay, so we got this is the translator of test. This is the right paper, the key aspects. These are the contributions. These are the strength, and this is the weakness. So as you can see, it was able to actually take the whole PDF, answer questions on top of that, and it was able to more or less correctly summarize the strength and the weakness. So this is how you can use your own pipeline or use just your own code to interact with the API, the model. So I'm using Gemini 1.5 model for this. Now, since we talked that we also are talking about Gemma, how we can do this same thing in Gemma. For that, I need to share my screen again. Okay, so I'm actually running a Gemma model right now. In my local machine. Let's make it bigger. Okay, so that's my client endpoint. I'm using LM Studio to run the model, and I'm running the smaller model, the 2 billion parameter model. This is running right now from my machine. And okay, so this is a multi-turn chat we have given it, and what we want to see is that, okay, if I ask it that introduce yourself, someone, so we just want to see if it works or not. So when I run it, here is the output. So it's trying to run it. Okay, so it's running pretty fine in my machine. If we look at the server logs, I can actually see the logs. So this is the server log. Let me make it bigger. Yeah. So this is what we just sent. So these are the streaming responses, and this is the model, this is the temperature, can you tell me a poem, this is what I just did, this was the role, this was the assistant, and this is how we work. So as you can see, and this was the API endpoint where we tried to connect using this. Okay, so is the screen sharing not being shared? Oh, now it is. Okay. So the previous, some people can see, some people cannot. Okay, I'll very quickly go through the demo again. So what we did just right now is here I have a Gemma API running in the in my machine right now, and okay, let me stop this and clear this. Okay, so this is the API endpoint in my local host, and this is kind of the role and system I'm giving. You are an intelligent assistant. You always provide helpful information, and hello, introduce yourself to somebody. And I am running the Gemma 2 billion parameter model, which is pretty small model, the smaller models. And I just want to run it and chat with it. So once I run it, here I got it. So I'm language AI designed to assist with tasks and everything. So I'm saying, oh, okay, of course. So since I asked specifically for a person, it won't, so this is the responsible AI guidelines, it won't do that. But if I ask just this, so here we interact with the model, and I just showed you how it works, and I can show you the server logs we have right now. Let me open the log. Okay, so this is the server log. Let me make it a little bit bigger. Okay, so this is the can you tell me poem. We have the response, and this is the question beforehand, which I tried, and it gave me this content that no, I wouldn't be able to provide. So this is how you see this is actually running in my machine, and this is the open source model, and this is how we can kind of interact with it. So with that, I'm going to go with the resources. I see a couple of questions regarding Gemma and Gemini resources. So these are the resources. And the notebooks you just saw and a lot of other notebooks, they are all available in this. I can just show you, including the uh, PDF reader you just saw. So they are all available in that link I just showed. That's in GitHub. And apart from that, these are other resources which are available to you. So you have the doc page, you have the different Gemma debugging tutorials, the technical reports, and also the Google Kubernetes engine tutorials available in these links. With that, I'll probably start taking the questions. Okay, Bill, should I start with the questions?
Yes, go ahead. I already posed the question over there.
Yeah. So this is not going to be a straightforward answer. So Llama 3 and Phi 3, do you want to compare between these two or these two with Gemma or Gemini? So I'll answer for
That's a
that.
good question. I guess you can just. I think it means the two with the
Yeah.
Gemini.
Yeah. So these two are actually very different model families. Phi, the whole family of models of Phi are from Microsoft very specifically to showcase you can have a very small model but with still much powerful capabilities. The Phi 3 is literally kind of, for example, compare that with Gemma 2B. So that's a smaller model, but what it can do, how much, can it still trade blows with a much bigger model like a 7 billion parameter models? Most of the places you will see it cannot. But Phi 3 is literally the proof, or Phi 2, or these smaller models that work very specific task with a very high quality data. You can still trade blows or even sometimes surpass in very specific tasks in a bigger model. Llama 3 has a lot of different parameter versions available. Of course, if you have a Llama 3 70 billion parameter model, and if you want to compare it to Phi 3, most of the reasoning and even math or most of the other tasks, you will probably see Llama 3 will do better. Same with if you were to compare with the Gemma different parameter models. So right now there are a lot of models for time series data. For example, Google itself has a model for time series data. I can point you to the link. So it's I'll point you to the, where is that? Point you to the paper for it. So where is the archive? I believe this is that one. I'll put it in the chat. So Google has one own model called Times FM, Times Foundation model. Then Amazon Science has its own model called Chronos, and I think CMU came up with also another model with time series. But you will see a lot of people coming up with very specific foundation models for time series. So if you want to do time series forecasting, I think going for one of these models will be better bet. You can also use the existing models. For example, the Amazon Sciences Chronos model is actually based on Google's T5 model, and they have modified it to work on time series data. So those are T5 flat model. So those are also some of the things you can look forward. But yes, there are already models available for those, and I'll put them in the chat. So the data sources into GemmaGK environment, there are a lot of different ways. You can literally connect with BigQuery to do that. I mean, if you have data in BigQuery, you can of course connect with Google bucket storage, like or GS storage directly to get your data. You can also connect with any of the existing connectors which has connections with GK to do that.
All right, great. Well, thank you so much for the presentations, and I will, because of the time constraint, we're going to have, later on we have the workshop sessions. So we're going to stop the tech talk sessions, the Q&As. The good news, actually, later on, Ramib are going to lead the workshop. So if you have more questions, I see actually you have a lot of questions in the comments, and you actually have the plenty of time to ask the questions on the workshop and also on the tech talk. So with that, we concluded today's tech talk sessions today. And we're going to take a 5 minutes break since we have quite a lot of content tech talks coming in the morning. So we're going to take a 5 minutes break, and then we will go into the workshop.
Thank you, Bill. And you're all, of course, like very much welcome to email your questions or connect with me in social media. I'm not much active in X anymore, but Threads, Mastodon, Blue Sky, or any of the other 1,000 parts I'm available.